Perhaps the simplest way to understand prediction errors is to think about Pavlov and the dog. So if you think back to what Pavlov did, Pavlov basically spent a lot of time dinging bells, and at the same time, he presented the dog with some food. Imagine the proverbial dog bone. And he already knew that if you just hold up the food, the dog drooled. But then if you do this lots and lots and lots, and you only play the bell, you find out that the dog drools to the bell. And this is what we call classical conditioning. You've been conditioned to a lot of things in your life. For instance, if you hear scary music in a movie, you've learned that that predicts something frightening happening. Now, let's think about this specifically in terms of values. You've got your bell, which can be dinged and it makes its little musical sound. Forgive the graphics there. And you've got the dog bone that we mentioned. Imagine that there is a value associated with this bell, and that value is 0 at the start of learning. And imagine that then the dog gets food, and there is a value for food. So how does the dog learn? How does it come to realize that the bell predicts the food? Well, we have to do a bit of math to explain that. Let's think of this in terms of a table and just look at what happens to these values as we learn. The very first time the dog hears the bell, it has no value. But the food has value, and that's essentially what makes the dog drool. But how does the dog actually learn? Well, in this case, you could simply say there is a prediction error, and it's the difference in value between food and the bell. So in this case, it's 100 minus 0, or 100, and that's the prediction error. Early in learning, the bell has 0 value because the dog knows nothing about it. But the food does have value, and that's what makes the dog drool. And you can compute a prediction error, which is simply the value of the food minus the value of the bell. So in this case, 100 minus 0 is 100. So if you think about stages of learning and how learning works with prediction errors, you first always compute your prediction error. Now, what does that prediction error actually do? Well, it's used to change values. Now, how does that happen? Again, it's a little bit of math and it's pretty straightforward, which is we can say that the new value of something is equal to its old value plus a prediction error. So in this case, this math would give us 100. The old value was 0, the prediction error is 100. Now it's a little bit trickier than that, because if you think of what that means, it means you've just conditioned your dog in one trial. So there's another factor at play here, which is something called a learning rate. And the learning rate is a decimal which just really relates to how quickly the animal can learn. Dogs learn pretty slow, so let's put this at a 0.1. So what that actually means is that the value that's going up is only going to be 10. Now on trial 2, the dog still gets food, but the prediction error is now 90. And if you redo the math at the bottom, what you'll see is the new bell value is going to be equal to the old value, which is 10, plus the prediction error times our friend the learning rate, which is 19. And you can imagine that this keeps happening and keeps happening and keeps happening. Try it out for yourself. And what you'll see is that the value of the bell does something like this. And hopefully that reminds you of something we talked about earlier in the course. Conversely, if we look at the size of the prediction error, you'll notice it does something like this. So let's summarize this. What's a prediction error? A prediction error is a difference in values. One way to think about this is it's the difference between what you expect to happen and what actually happens. Think about an exam situation. You expect to have 80% and you actually get 60% and you have a prediction error. Formally, we talk about the difference between the current state, where you are, and the value of the previous state. Think back to the exam example. The current state is getting back your exam. The previous state is how you felt when you finished your exam. And it's important to realize that learning is always a two-step process. Once you've computed this prediction error, you can use it to update the new value of the current state. In this way, our expectations come to align with our outcomes. Let's finish with pizza. You order pizza and you have no idea what pizza is going to taste like from this particular restaurant. So you have no expectation. That's your previous state. When the pizza arrives, it's amazing. That's your current state. So there is a prediction error, and you use this to increase the value for that pizza place. And it comes to have a high value. And if you keep ordering pizza over and over again from this place, your value will come to align, or your expectation will come to align with the actual value of the pizza from that store. And you can think about a different example, which is what happens when you get something you don't like. You're expecting good pizza and it's actually bad. Your previous state value is high, your expectation. Your current state value is lower, so you have a negative prediction error, and that will decrease the value of the choice you made, thus making it less likely you'll choose that again.